Good afternoon, my viewers. First of all, I want to introduce myself. I am Ankit Acharya, working as an assistant professor in Hasmukh Goswami College of Engineering. And today my content is, I want to explain you the GTU question paper solution of June 2010 of the subject of vector calculus and linear algebra. So here is my content: vector calculus and linear algebra GTU paper solution of June 2010. First question 1a. This question asked in 6 marks in this GTU question paper. Solve the following system for x, y, z, where first equation is minus 1 upon x plus 3 upon y plus 4 upon z is equal to 30. Second equation is 3 upon x plus 2 upon y minus 1 upon z is equal to 9. Third equation is 2 by x minus 1 upon y plus 2 by z is equal to 10. So let's take 1 upon x is equal to a, 1 upon y is equal to b, and 1 upon z is equal to c. So these three equations convert into a minus a plus 3b plus 4c is equal to 30. 3a plus 2b minus c is equal to 9. 2a minus b plus 2c is equal to 10. So the matrix equation, the augmented matrix or the matrix equation of this system is minus 1, 3, 4. Just first row is exactly the coefficient of a, b, c, right? So from this matrix we find first of all a, b, c, and then from a, b, c you will get the value of x, y, z. Okay, so just keep in mind that our main target is to find x, y, z, but we already take 1 upon x, 1 upon y, 1 upon z as a, b, c. So first you will get the value of a, b, c, and from a, b, c you will get x, y, z. Okay, so the matrix equation of this system is minus 1, 3, 4, 3, 2, minus 1, 2, minus 1, 2, a, b, c, that is equal to 30, 9, 10. So try to convert this matrix into a row echelon form. How to convert this matrix into a row echelon form? Just try to keep in mind that all the conditions of row echelon form. First condition to become a row echelon form is the leading entry. Just try to see what is our leading entry in first row. From that leading entry, below that leading entry, all the elements should be 0. In second equation, with the same process, that below that leading entry all the elements should be 0. Now whenever we are going from top to bottom, right, whenever we are going from top to bottom, the leading entry is going from left to right. Okay, the leading entry is going from left to right, and whenever we are going from whenever we are going from top to bottom, the leading entry is going from left to right, and if there is any zero row, it should be the bottom of the matrix. If these three conditions are satisfied, we can say that the given matrix is in row echelon form. If these two conditions are added in these three conditions, then we can say that a matrix is in row echelon form. So what that two conditions? The first condition is leading entry must be 1, and the second condition is if there is any leading entry, below that leading entry and above that leading entry, all the elements should be 0, right? That means in that column, except the leading entry, all the elements should be 0. Okay, so if these two conditions are added, then we can say that a matrix is in row echelon form. So if we want to solve the linear system of equation, right, if you want to solve this type of linear system of equation, we have to convert. So first of all we write down the matrix equation, and then we have to convert that matrix into a row echelon form or reduced row echelon form. Okay, otherwise it directly to solve this type of linear system of equation, it's quite difficult, and maybe your answer is incorrect, right? So that's why we convert this matrix into row echelon form. So just our first process, you can see what is our first leading entry in first row, -1, right? Below that leading entry I want to make 0, so that's why we multiply first row here is our augmented matrix: minus 1 3 4 2 3 2 30, 3 2 minus 1 9, 2 minus 1 2 10. So here was the first row, that we multiply first row with 3 and add into the second row, and we multiply first row with 2 and add into the third row. So that's why first row is as it is. The second row become 0, 2 minus 2 plus 9, 2 plus 3 into 3, right? So that is 11. Then minus 1 plus 3 into 4, that is 12 minus 1, that is 11. Okay, and 9 minus 3 9 plus 3 into 30, that is 90 plus 9, that is 99, right? So the second row becomes 0 11 11 99. Now we multiply first row with 2 and add into the third row. So that's why the third row become, the first element is 0, second is minus 1 plus 2 into 3, that is 6 minus 1, that is 5. Then 2 into 2 minus 3 into 2 minus 2 into 4, that is 2 minus 8, that is 10. Okay, 2 plus 8, that is 10. So, and then 10 plus 2 into 30, that is 60 plus 10, that is 70. Okay, now next is we multiply second row with 1 by 11. So second row become, so the second row become 0 1 1 9. First and third row are as it is: minus 1 3 4 30, 0 5 10 70. Okay, now next process. Now first row we have leading entry, below that leading entry all the elements are 0 now. Second row we have leading entry 1, below that leading entry 5, so we have to make that 0. So that's why we multiply second row with minus 5 and add into the third row. So that's why minus 1 first and second row are as it is, third row become now 0 0 5 25. So minus 1 3 4 30, 0 1 1 9, 0 0 5 25. It is clear that rank of A, that is equal to rank of augmented matrix. Both the matrix have leading entry 1. Okay, both the matrix have leading entry 3. Both the matrix have rank 3. So number of that is equal to number of variables. Hence system is consistent and it has a unique solution. We have minus a. So from the first row we have minus a plus 3b plus 4c is equal to 30. From the second row we have equation b plus c is equal to 9, and from the third row we have 5c is equal to 25. So c is equal to 5, right? Put that value in second equation, b is equal to 4, right? Put that value in second equation, you will get b is equal to 4. And if you want to find the value of a is equal to, just make a as a subject. So a is equal to minus 30 minus plus 3b, so 3 into 4, b is 4, so plus 3 into 4 plus 4 into c, so 4 into 5, that is equal to minus 30 plus 12 plus 20, that is equal to 2. So hence the solution x is equal to 1 by 2. Now a is equal to, you will get a is equal to 2, b is equal to 4 and c is equal to 5, and we know that a is 1 upon x. So that means x is, if you want to find x is 1 upon a. So x is equal to 1 by 2, just inverse of all the elements. So x is 1 by 2, y is equal to 1 by 4 and z is equal to 1 upon 5. Okay, so here is the solution of this question. Next question, question 1a. In this question paper, in this question 1, you have to attempt any 2 out of 3, right, and each have 3 marks, right? So here is a question 1a, first question, and this is a question 1a, second question. right? Find A inverse using row operations. If A is equal to 1 0 1 minus 1 1 1 and 0 1 0. So using row operations, that means you have to use Gauss-Jordan method to find the inverse of this matrix. So that is equal to augmented matrix A I. So first matrix, you can see first matrix is our A and the second matrix is our identity matrix, standard matrix, right? Identity matrix. Now using some row operations, what we have to do, we try to using some row operations, we try to do that our identity matrix is our left hand side, and whatever the right hand side you will get, that is our inverse of the matrix. So in the first matrix, in the first step, you see left hand side we have matrix A and right hand side we put matrix identity matrix. Now using row operations, what we are trying to do, in left hand side we have, in the last step, in left hand side we want their identity matrix, right? And whatever the right hand side matrix, that is exactly our inverse of the matrix. Okay, so 1 0 1 minus 1 1 1 0 1 0, that is equal to 1 0 0, left hand side our standard identity matrix, so 1 0 0 0 1 0 0 0 1. Okay, so now we multiply first row with 1 and add into the second row. So 1 0 1 1 0 0, first row is as it is, second row become 0 1 2 1 1 0. Okay, 0 1 2 1 1 0. Just add first row in second, just add first and second row and put that value in the second row. Okay, so 1 minus 1, that is 0, 0 plus 1, that is 1, 1 plus 1, that is 2, 1 plus 0, that is 1, 0 plus 1, that is 1, and 0 plus 0 0. So second row becomes 0 1 2 1 1 0. Now third row is also as it is, 0 1 0 0 0 1. Now you can see in first column, left hand side, in first column we have leading entry 1, below that leading entry now we have 0. In second row we have leading entry 1, below that leading entry we want make that 0. Okay, above that leading entry we have already 0. So next process is we multiply second row with minus 1 and add into the third row. We multiply second row with minus 1 and add into the third row. So first and second row are as it is. First and second row are as it is, 1 0 1 1 0 0 0 1 2 1 1 0. The third row become, now you can see 0 minus 0, that is 0, 1 minus 1, that is 0, 0 minus 2, that is minus 2, then 0 minus 1 minus 1, 0 minus 1 minus 1. Okay, and 1 minus 0, that is 1. So the third row become now 0 0 minus 2 minus 1 minus 1 1. Now in third row we have leading entry minus 2. So in that, instead of minus 2 we want 1. Okay, instead of minus 2 we want 1 there. So that's why we multiply third row with minus 1 by 2. Okay, we multiply third row with minus 1 by 2. So the third row becomes 0 0 1 1 by 2 1 by 2 minus 1 by 2. Okay, 1 by 2 1 by 2 minus 1 by 2. So first and second row are as it is, first and second row are as it is, third row becomes 0 0 1 1 by 2 1 by 2 minus 1 by 2. Now next process, you can see in the left hand side, in the third column we have leading entry 1 in the third row. Above that leading entry we want make there 0. So that's why we multiply third row with minus 2 and add into the second, and we multiply third row with minus 2 and add into the second row, and we multiply third row with minus 1 and add into the first row. So that's why the third row is as it is. The first row become, we multiply, you can see we multiply third row with minus 1 and add into the first row. So just see the first row, that is 1 minus 0 1, 0 minus 0 0, 1 minus 1, that is 0, right? The right hand side, 1 minus 1 by 2, that is 1 by 2, 0 minus 1 by 2, that is minus 1 by 2, and 0 minus minus 1 by 2, that is 1 by 2 plus 1 by 2. Okay, so the first row become now 1 0 0 1 by 2 minus 1 by 2 1 by 2. The second row, the second row, we multiply third row with minus 2 and add into the second row. So that's why the second row become 0 1 0 0 0 1, 1 minus 1 by 2, that is 1. We multiply third row with minus 2 and add into the second row. So that's why 1 minus 2 into 1 by 2, so that is 1 minus 1, that is 0. 1 minus 2 into 1 by 2, okay, again 0, and 0 minus 2 into minus 1 by 2, so that is 1. So you can see in the last step, in the last matrix, you have left hand side, you have exactly the identity matrix 1 0 0 0 1 0 0 0 1, and the right hand side we have matrix 1 by 2 minus 1 by 2 1 by 2, first row 0 0 1, and second row, and 1 by 2 1 by 2 minus 1 by 2, third row. That is exactly the inverse of the given matrix. So that's why A inverse, that's why our A inverse, that is equal to 1 by 2 minus 1 by 2 1 by 2 0 0 1 1 by 2 1 by 2 minus 1 by 2. So 1 by 2 will be outside from the matrix, 1 minus 1 1 0 0 2, okay. So 1 by 2 will be common out, so that's why 1 minus 1 1 0 0 2 and 1 1 minus 1. So here is the complete the solution of this question. Next question, question 1a, third part. Find the standard matrices for the reflection operator about the line y is equal to x on R3 and the reflection operator about the yz plane on R3. Okay, so here is the solution. A reflection matrix transforms every vector into its image on the opposite side of a mirror, right? A reflection matrix transforms every vector into its image on the opposite side of a mirror. So the reflection operator of a vector